Threat Arrest, Cybersecurity Threats and Threat Actors Training, Assurance-Driven Multi-Layer End-to-End Simulation and Training, funded by the European Union Horizon 2020 program.
During this past year, we've seen factories shut down, critical medical procedures in hospitals delayed, nations reverting to paper voting because of cyber attacks or the threats of cyber attacks.
Major challenges arise when trying to preserve the security of cyber systems due to the inherent difficulties of identifying the vulnerabilities of such systems, selecting appropriate security controls for them, and preserving the end-to-end security in a dynamic, ever-changing environment. To be able to fortify a cyber system against potential attackers, it is necessary to train all the actors to good security practices and raise their awareness.
However, several defense mechanisms with different capabilities exist, making it difficult to establish effective defense strategies. In response to these needs, Threat Arrest aims to develop an advanced training platform incorporating emulation, simulation, serious gaming, and visualization capabilities.
The Threat Arrest platform comprises of a number of tools. The first one is the Assurance tool, which supports the continuous assessment of the security of the cyber system through the combination of runtime monitoring and dynamic testing in order to provide information about the status of the actual cyber system. It also collects runtime system events and generates alerts that provide the basis for setting up realistic simulations. The simulation tool that generates synthetic system logs and simulates individual cyber system components and networks of such components to enable the simulation of entire training scenarios defined in CTTP programs. The emulation tool, responsible for the generation of the emulated cyber system components and their interconnections in physical, software, architectural levels. Next comes the gamification tool that hosts various serious games, scenarios, and training evaluation mechanisms that will enable trainees to develop skills in being resilient to and preventing social engineering attacks, for example phishing, impersonation attacks, etc. The games to be provided will be driven by the threats and assumptions specified in CTTP modules. The training tool, which supports the definition of CTTP modules and programs, the presentation of learning materials, exercises of CTTP programs, enables trainee actions in response to cyber threats, interactions with simulated and/or emulated cyber system components, trainee performance evaluation, CTTP program evaluation, and adaptation. And finally, the visualization tool that enables the graphical representation of simulations and emulations, the effect of training actions on simulated and emulated systems, as well as the status of the underlying components.
Now we will present the pilots that will be used to evaluate the project. The Smart Energy Systems pilot focuses on the generation of electricity from home solar array installations. The end-to-end security of this scenario is a key requirement that provides anonymity, integrity, availability, and privacy of all data exchanged between the home appliances and the grid.
The healthcare training scenario showcases cybersecurity training tailored to healthcare organizations. This pilot prioritizes the threats relevant to specific size, IT infrastructure, and competence of the relevant organization.
The Smart Shipping application envisions to validate the Threat Arrest platform in the shipping industry. Within this pilot, training will be designed towards advanced cyber threats and security attacks related to machine failure, sensors failure, performance monitoring, subsystem failure.
The Threat Arrest project is expected to 1. Develop advanced educational and training methods and skills for high-risk and vulnerable industries. 2. Increase society's resilience to advanced cybersecurity threats. 3. Provide a holistic training experience.